Hello, good morning, everybody. This is going to be for Dr. Ang's 416 Instrumental Chemistry, and today we're going to be going over section 12D-3, Interpretation of Diffraction Patterns. So what is the identification? What are the diffraction patterns? How do you find that stuff, The identification of a species from its powder diffraction pattern is based on the position of the lines in terms of U or 2U and their relative intensities. The diffraction angle 2U is determined by the spacing between a particular set of planes with the aid of the Bragg equation. This distance d is going to be calculated from the known wavelength of the source, so that's the x-rays that you're using, yada yada, and the measured angle. If you need to review the Bragg equation, we got 2d sine theta equals n wavelength, where d is the spacing between the planes, n is the order of diffraction, and we can also only have Bragg reflection when n wavelength is less than or equal to 2 times the distance or the spacings in between the plane. You can't use visible light, that's just too big. So you gotta, x-rays. Looking at this, the ICDD, awesome logo, it's the International Center for Diffraction Data. According to the website, they got like 1 million different materials logged, so they've been putting in work over there. So there's a lot of good stuff. So each record in the database contains a wealth of information regarding the substances and materials. So they got the name, formula, composition, color, line strengths, melting point, mineral classification, density, just a bunch of other stuff. But an unfortunate reality is if the sample isn't, a single thing, if it contains 2 or more crystalline compounds, then the identification just becomes more and more complex. So you can use various combinations of more intense lines until a match can be found. And also you can use some stuff having to do with computers to search and match the data to find what you're looking for. Danke.